Hello friends, so today we are going to see a problem on based on the properties of DFT. So the problem says that if x of n is given to me, which is 1, 2, 3, 4, then it says that find the DFT and get x of k. So we will use the basic formula of DFT and we will find the x of k in this case. But then the problem is extended as using result obtained and not otherwise, find DFT of the following sequences. And the sequences are given as x1 of n is the first sequence given as 4, 1, 2, 3. Then x2 of n is given as 2, 3, 4, 1. Then x3 of n is given as 3, 4, 1, 2, and x4 of n is given as 4, 6, 4, 6. So we have 4 sequences given and we wanted to find x1 of k, x2 of k, x3 of k and x4 of k, but we cannot use the formula because it is given that we need to, it has been mentioned in the problem that using the result obtained, that means we have to use the result obtained in the first section and not otherwise. That means this restrict us from using the formula. So even if I use the formula and get the result, it's not correct, it's wrong. I have to compulsorily go for the properties. So whenever in the problem they write or specify not otherwise or do not use the formula or use the formula only once, such kind of statements will lead you that this problem is based on properties. So whenever these 3 sentences are mentioned, that you cannot use not otherwise or written as use formula only once or is been written as, so this is not otherwise, use formula only once, and then using results, using result of previous, such kind of sentences will lead you to say it states that the problem is based on properties. You have to use the properties of DFT. You cannot use the formula and give the answer. Even though the answer is correct, you will not get marks because it has been mentioned that you have to use properties. So let us proceed with this problem. So now they have mentioned that for the first time I can use the formula. So for the solution, given x of n is 1, 2, 3, 4, by using definition of DFT, I will get x of k equals to summation n going from 0 to, now it is going from n minus 1. So what is capital N over here? It is 1, 2, 3, 4. So capital N over here is 4. So it is n minus 1, that means it will go up to 3 x of n e raised to minus j 2 pi n k by n. Okay. So let us put the values of n. So I will get x of 0. If I put 0 over here, I am going to get e raised to 0 plus x of 1 e raised to 1, when I put it will get minus j 2 pi k by n is 4, right. Then plus x of 2 e raised to minus j then that gives me 2 is already over here. I am putting 2 for n, it gives me 4 pi k by 4 plus x of 3 e raised to minus j. Now here it gives me 4 pi, I put n is equal to 3, n is 3 over here, so it will give me 6 pi k by 4. So that is what my equation is. Then I will go on putting the values of k now, because the equation is totally in terms of k now, right. So I will put k equals to 0 first, because in the definition k goes from 0, 1, 2 and so on till n minus 1. In our case it is 3. So when I put k is equal to 0, I am going to get x of 0, which is equal to this x of 0 stands for this, that is 1, e raised to 0 is 1, plus x of 1 which is 2. Then you can see that when I put k is equal to 0 here, this becomes e raised to 0, which is nothing but 1, plus x of 2 is 3. Here if I put k is equal to 0, again it will be 1, plus x of 3 is 4, again k is equal to 0, here it will go to 1. So the answer is 1 plus 2, it is 3, plus 3 is 6, plus 4 is 10. Always remember that the first sample in k, that is x of 0, this sample will be addition of all the samples in the sequence. So whenever you get an answer, you should always verify that whether your calculations are correct or wrong by just adding all the sample values, and you should get this. Okay. So first sample is nothing but addition of all the samples in the given sequence. So this is x of 0. Similarly, we can find for x of 1, x of 2 and x of 3. Now this is a bit lengthier process, that every time we will put k, we will find sines and cosines and it will go on. So it will take lot of time. So to reduce your time in calculation, we will use a shortcut method. In this shortcut method, I will work out with this element such a way that it will reduce the calculation. So what we do is, we use matrix method. So that is really simple and gives the answer immediately, because the problem is lengthier, because we have to use properties also. So if we increase the calculation part in the first section also, it will make the problem more lengthier and time consuming. So to make the time, to reduce the time consumption, we will use matrix method for solving the first section. Okay. So now in matrix method, what I do is, we will have x of k on one side, which is my result. I will have one matrix over here, and then we will have another matrix of x of n. Now this matrix will be 1 cross n length, this matrix will also be 1 cross n length, or depending on the multiplication you might get n cross 1 and n cross 1, no problem. Okay. I cannot use 1 cross n in this case, because my matrix that I am multiplying over here is n cross n. So I have a matrix over here as n cross n. So if I keep 1 cross n, the multiplication will not suffice, because the internal arguments should match, or the internal dimension of the matrix should match for matrix multiplication, whereas in this case it matches, right. So I can use n cross n and I will get n cross 1 as an element. Then how can I get 1 cross n? 1 cross n is simple, you interchange the positions of the matrices. You keep x of n first and you keep n cross n matrix later, that will give me x of k as 1 cross n. Now if I interchange the positions, I am going to get the multiplication product as 1 cross n. So it is possible. So both the combinations are possible. In the given scenario, the only possible combination is n cross 1 multiplied by n cross n. Now, let us see what is this matrix is all about. So, this matrix is called as Twiddle matrix. So, this matrix is called as Twiddle matrix, and we will be playing with e raised to minus j 2 pi nk by n factor. Okay. So, we have seen that if I go on putting the values of n, I will get a row, and when I put a value of k, I will get a column. So, for the first row, n will be equal to 0. So, whenever I will put n is equal to 0, I will get a row, and whenever I transit for k, I will get another column or another row. Okay. So, n changes in row and k gives me new row. Okay. So, let us define it, let us find it. So, for this matrix, I will write first element is e raised to minus j 2 pi, n over here is 0, k by n I am writing. So, here 0 stands for n is equal to 0, and for this whole column n will be equal to 0. Okay. Then next element will be e raised to minus j 2 pi, okay, n over here is 1 k by n. Okay, I am purposefully writing k over here to just give you the flavor of how n varies in a system. So, n varies and you will get n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3 and so on. Okay. Now, when I transit from n from k, like for k is equal to 0 if I have, so that will be my first row, k is equal to 0. So, here my k will also be 0. So, here the k will go to 0, here also k will be 0 and so on. Okay. So, based on the product of n and k, let us complete the matrix. So, based on the product n and k, I will write a complete matrix now. So, for the complete matrix, I will get here as e raised to 0, then again e raised to 0, e raised to 0 and e raised to 0 if my n is equal to 1. Then I will get here also e raised to 0, e raised to 0, e raised to 0. Here is n 0 and here is k equal to 0. So, k is going like this, n is coming like this. Agreed. So, because I put k 0, this will be 0, this will be 0, this will be 0, this will be 0. And because n is 0, whatever value of k I will put, it will always be 0. So, my k will be 1 over here, k will be 2 over here and k will be 3 over here. Whereas, here n will be equal to 1, n will be equal to 2 and n will be equal to 3. Okay. So, because I am starting from 0, so it will go till 3, it is also starting from 0, so it will go to 3. Now, here I will get e raised to, now n is 1, k is also 1. So, I will get here n is 1 and k is 1. So, I will get minus j 2 pi by n. So, it will be minus j 2 pi by n is in this case is 4. So, it will be e raised to j pi by 2, right. Then here n is 2 and k is 1, n is 2, it will give me 4, k is 1, so it will be 4 again. So, 4 upon 4 it will give. So, e raised to minus j 4 pi by 4, right. Now, n is 3, so it will give me 6, again k is 1, so it will give me e raised to minus j 6 pi by 4, isn't it? Correct. Now, again if I go further, here n is 1 but k is 2 now. So, when n is 1 it will give me 2 pi and k is 2. So, 2 into 2 will give me 4. So, it will be e raised to minus j 4 pi by 4. Now n is 2 and k is also 2. So 2 into 2 will first give me 4, 4 2s are 8. So e raised to minus j 8 pi by 4. Then I will go for n is equal to 3 and k is equal to 2 will give me 6, 6 2s are 12, e raised to minus j 12 pi by 4. And finally, when my k is 3, n is 0, okay, this is fine. N is 1 and k is 3, so 3 2s are 6. So e raised to minus j 6 pi by 4. Then n is equal to 2 and k is equal to 3, so 2 3s are 6, 6 into 2 is 12, e raised to minus j 12 pi by 4, and then n is equal to 3 and k is equal to 3, 3 3s are 9, 9 2s are 18. So this is how all the elements will be built up in the given matrix, which we called as a Twiddle matrix. This factor is called as Twiddle factor. Okay, and generally to write huge factor like this, it is better to write some small value. So we write like this, e raised to nk. So Wn raised to nk is called as the Twiddle factor. So now here there is no minus sign over here, but internally there is a minus sign in the e. Okay, so Twiddle factor don't have minus sign, but e have a minus sign. So whenever I say w plus nk, that itself determines that internally there is a minus sign in the calculation. So this is how the matrix will be built up. Okay, so further calculation will give me, this will be pi by 2, this will be pi, this will be 3 pi by 2, this will be pi again, this will be 2 pi, this will be 3 pi by 2 or 3 pi, this will be 3 pi by 2, this will be 3 pi again, and this will be 9 pi by 2. Okay, so if I go on calculating it, I will get the matrix as e raised to zeros will be all ones, and e raised to I want pi by 2. So it's better that we will make a circle. Okay, on this circle I have this as plus 1, this as minus 1, this as j, and this as minus j. Okay, so I go like this, w4 raised to 0, w4 raised to 1, this will be w4 raised to 2, and this will be w4 raised to 3. Okay, so I go w4 raised to 0, it's all 1, so this is all 1s. Next factor is w4 raised to 1, so it is minus j. Okay, because here my n is going as n is equal to 0, 1, 2, 3, and here it is given as k is equal to 0, 1, 2, 3. So w I'll get 4 raised to 1, then w4 raised to 2, which is minus 1, w4 raised to 3, which is j, w4 raised to 2, w4 raised to 2, which is minus 1, w4 raised to 4. Now here you can see only till 3, but it is on a circle, so where it will be 4, 4 will be here. Okay, so w4 raised to 0 is equal to w4 raised to 4. So here I will get 1, then I have w4 raised to 6. Now here I ended with 4, 5, 6, so it will be minus 1. Then w4 raised to 3, which is j, w4 raised to 6. So we end up 6 over here, which is minus 1. Then w, because it is 4, 5, 6, w 4 raised to 9. So here we end up with 6, 7, 8, 9. So 9 is minus j. So it is really easy to remember this. For a 4 by 4 matrix, or for n is equal to 4, first row, first column all ones, minus j, minus j. So we have all ones, your all ones, minus j, 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 minus 1, minus 1, minus 1, minus 1 and 1. So, this will always happen whenever you have a 4-point DFT or a 4 cross 4 matrix in a DFT. So, this matrix will always occur. So, it is really easy. First row, first column 1, minus j, 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 that is the diagonal elements, minus 1, minus 1, minus 1, minus 1 and then center you write with 1. Okay. Now, using this matrix, my x of k will be really simpler. So, my x of k will be equal to this matrix, which is 1, 1, 1, 1, 1, 1, 1 over here, minus j, minus 1, j, minus 1, 1, minus 1, j, minus 1, minus j. And then I get my x of n. For x of n, my value is 1, 2, 3, 4. So, let us see it in the section, that how to get x of k fast. X of k will be equal to, now it is just a row to column multiplication. So, this is a column matrix, I will multiply by the given row. So, 1 plus 2 plus 3 plus 4, that is the first element is addition of all, which is 10. Okay. Second, 1 minus 2 j minus 3 plus 4 j. So, for safer side, let us write it is 1 when I multiply this, then it is minus 2 j, then it is minus 3, then it is plus 4 j. Okay. Next is 1, then minus 2, then plus 3 and then minus 4. Finally, 1, okay, then plus 2j, then minus 3, then minus 4j. Its answer is 10. Here it will give 1 minus 3 is minus 2, minus 2 plus 4j will give me plus 2j. Here the answer will be minus 2 minus 4 minus 6, minus 6 plus 3 is minus 3, minus 3 plus 1 will give minus 2, and here it will give me minus 2 and it will give me minus 2j. So, hardly 3-step answer, just you need to know this and it will give you the answer. So, this method normally is used when you are solving a first section or when you are using your DFT once in the given DFT problem. So, you never use the definition directly or you never substitute in the definition, rather you use a matrix method to solve the problem, so that you can get the section 1 answer quickly. Now, once the section 1 is over, we need to concentrate on the section number 2. So, from section 1, we got x of k as equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So, this is how what we got in the first section. Now, we will concentrate on section 2. So, for section 2, let us take the first sequence. X of n equals to x1 of n equals to 4, 1, 2, 3. So, whenever you are solving a property problem, the new given sequences should be brought in synchronous, or we can say that we should find some sort of relation with the given x of n whose x of k is known to us. Okay. So, we have given x of n whose x of k has been calculated. So, I need to bring the given x of x1 of n or the new sequences in relation with x of n, and then just do the tweaking part which will result into the answer of x1 of n. Okay. So, we cannot use definition here, we cannot use a formula here, we have to use property because it is mentioned that not otherwise. So, here what I can see is, if I will see my x of n, let us pictorially draw it. If I will see x of n as 1, 2, 3, 4. So, this is 1, 2, 3, 4. This is given my x of n, and my x1 of n is 4, then 1, then 2, and then lastly 3. So, I have 1, 2, 3, 4 as x of n, and x1 of n is 4, 1, 2, 3. So, can I see some relation in between them? Yes. In the first place I want 4, whereas last place I want 3. So, if I shift this signal, because it is periodic, there will be one more sample on this side, which will be 4. So, because the signal is periodic, I will have one more sample with me, and that sample will be 4. So, I have one more sample over here, which is 4. I have another sample over here, which is 3. One more sample, 2 and 1, and this will go on this side also and this side also, because the signal is periodic. Now, given this as a window, given this much as a window, that is a 4 samples, if I shift, what will happen? This sample will jump out and new sample will jump in. So, this side the 4 will come inside and this side the 4 will go outside, and it will look very similar to the x1 of n, or it will be same as that of x1 of n. So, I can say that x1 of n is equal to x of n minus 1, because I am delaying the signal by 1. So, if I delay a periodic signal, I will always get 4 samples because it is a periodic signal. So, it will be, the new sample will be 4, 1, 2, 3. Okay. So, if I now apply, now what we have done? We have done a time shifting. So, this is called as time shifting. So, because I have shifted in time, I can apply time shift property, which is 4a. Okay. So, let us say to find DFT of x1 of n, okay, we use time shift property. So, let us use a time shift property. So, to use a time shift property, I will be dealing, just to recall, if I have x of n, its DFT is x of k, then whenever I shift the signal by L units, its DFT will be multiplication of x of k. Okay. So, I need to multiply by the minus L units, okay, and this is KL. Okay. So, I will do that. We have shifted, now here the L is equal to 1 for our problem. Therefore, x of n minus 1, its DFT will be equal to e raised to minus j 2 pi k by, now here for our case n is 4, x of k. Do we know x of k? Yes, we know x of k from the first given section, and then we can apply this directly to the given problem. So, our x1 of n, which is equal to x of n minus 1, its DFT will be, so I can write it as equals to x1 of k is nothing but e raised to minus j 2 pi k by 4 x of k. Okay. So, now I will take only this much part and I will write x1 of k is equal to e raised to minus j. If I cancel this, then I am going to get pi by 2 times of k x of k, right. Now, what will be x1 of 0? It will be e raised to k value is 0. So, I put 0 x of 0. From the previous problem, let me write here, x of k is nothing but 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So, this is my x of 0, this is my x of 1, this is my x of 2 and this is x of 3. So, I will be using x of 0 from here, which is 10. So, e raised to 0 into 10, which is nothing but 10. So, x1 of 0 is 10. So, for x of 1 we will be having e raised to minus j 2 pi. Now, here the k is 1 by 4, value of L is 1 and k is now 1. So, then we get x of 1 over here. So, our x of 1 is minus 2 plus 2j. I have to multiply it with e raised to minus j pi by 2. So, x1 of 1 will be equal to e raised to minus j pi by 2 into minus 2 plus 2j. Now, if we remember the fact that of same as that of Wn raised to nk, instead of now n, instead I have W 4 raised to Lk. Now, L is fixed over here, L is 1 over here. So, we can write it as W 4 raised to k. And what is the value of k in this case? Value of k in this case is 1. So, let us plot circle for this also. So, I have W 4 raised to 0, then W 4 raised to 1, then W 4 raised to 2 and W 4 raised to 3. This is 1, this is minus 1, this is minus j, this is plus j. Okay. Now, the factor that I have is e raised to minus j pi by 2. This similar thing I can write as x1 of 1 equals to, now here instead of e raised to minus j, I will write W with period as 4, L and k both are 1. So, I will write 1 x of 1. So, W 4 raised to 1 is over here is minus j, which is minus 2 plus 2j. So, minus j will give me plus 2j, minus of minus plus 2, because this minus will come inside, it becomes minus 2j square and j square is minus 1. So, it will be like this. So, I can write it as 2 plus 2j, that is x1 of 1. Similarly, we can go for x2 of j. So, for x2 of j, x2 of x1 of 2 will be equal to, now here the value of k is 2. So, I write e raised to minus j 2 pi, L is 1, k is 2 divided by 4 x of 2, correct. For here k is equal to, here k is equal to 2. Then again I can similarly write as W 4 raised to k is 1, k is 2, L is 1. So, that will be 2. So, from the previous circle we can say that this is W 4 raised to 0, W 4 raised to 1, W 4 raised to 2 and W 4 raised to 3. So, this is minus 1. So, in this case this factor is minus 1. So, I write x1 of 2 equals to minus 1 into x of 2 was minus 2. So that gives me plus 2. So x1 of 2 is plus 2. And lastly, x1 of 3, which is nothing but e raised to minus j 2 pi, L is 1, k is 3 divided by 4, x of 3. Now I will have w4 raised to 3, which is nothing but w4 raised to 3 is j. So x1 of 3, which is equal to j into, this is nothing but minus 2j. So that will give me minus 2j, okay, and j into j is j square, which is minus 1, and it will become plus 2. So I can write it as plus 2 minus 2j. Therefore, I can write x1 of k is equal to, first sample was 10, second sample was plus 2 plus 2j, x of 2 is 2 over here, and this is 2 plus 2 minus 2j. So without using formula, only by using the time shift property, I can find the DFT of any given sequence if there is a relation with the previous problem. Okay, so we have seen that there is a relation of x1 of n with x of n. So we have developed this using that relation and property, we got x1 of k. On the similar note, if we can find the DFT of the rest problems, now let us take x2 of n. x2 of n for our case is, for the given problem, x2 of n is 2, 3, 4, 1. So we wanted to have 2, 3, 4, 1 as a given problem. So I will take 2, 3, 4, 1. x2 of n is 2, 3, 4, 1. Let us draw this of n, x2 of n. I have, let us say this to be 2, then we have 3, then we have 4, and then we have 1. So we have sample as 2, 3, 4, 1, and x1 of n, x of n is 1, 2, 3, 4. This is 1, 2, 3, 4 with n over. Now can I find any relation with this? Now yes, we can find. We can see that there are 1, 2, 3, 4 over here also and 1, 2, 3, 4 over here also. Somehow I need to adjust this sequence to get this sequence. Now we know that here 1 is at the first position and here the 1 is at the last position. So I want 1 over here. Okay. Similar way, I want 2 to be on the first position. Again using the time shift property, or again using the time shifting principle, if I shift this on the right hand side, left hand side. So let us shift on left hand side. If I shift the signal on left hand side, then this 2 will be dumped out. Okay, not this signal, this signal. I need to shift this signal to achieve this signal. I need to shift this signal by to left hand side. What will happen? This 1 will be dumped out, 2 will take the 1's position, 3 will take 2's position, 4 will take 3's position. And who will come on the position of 4? 1 will take the position of 4. Okay. So if I shift the signal left hand side by 1, I will get this given signal. So I can say that x2 of n is nothing but x of n plus 1. This is time shifting, but this time it is advancement in time. Advancing, it is time advancing. When I say n plus 1 or plus k, then it is time advancing. So again we can obtain x2 of k by using time shift property. Okay, so if I use time shift property, then I can find x2 of k. So here I have x of n plus 1. So what is my L over here? So L over here is 1 plus 1. So its DFT is nothing but e raised to plus j 2 pi. Okay, L over here is 1. So k by 4 x of k. Fine. So that is all equal to x2 of k in this case. So I will find, so let us directly write this as w 4 raised to k minus k. That is because w is always having in minus values. So here the e is plus, so I should write minus over here. Now here x2 of k is equal to w 4 raised to k x of k, w 4 raised to minus k. Okay. Why I am putting minus? Because from the definition of Twiddle, what we have written for Twiddle is e raised to minus j nk by n. To this I have written Twiddle factor as w n raised to nk. So what will be e raised to plus j 2 pi nk? It will be w n raised to minus nk. Correct. So e plus, here it will be minus. Here it is minus, so here it will be plus in that fashion. So now in the given problem, I have e to be plus, so I will put a minus sign. Instead of n, I have L. Okay. Now x2 of 0, that is k is equal to 0. Of course, this will be w 4 raised to 0. Sign doesn't matter. X of 0. So that will be 10 again. So for you to recall, x of k is equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay, that is what my x of k is. So first value of x of k is 0. Next, x2 of 1 will be equal to w 4 raised to, here it is minus 1 x of 1. Now remember, when I draw a circle with the w having negative index, it will be like this, w 4 raised to 0, then here it will be w 4 raised to minus 1. Okay. Then you will have w 4 raised to minus 2 and then w 4 raised to minus 3. Here it is 1, here it is minus 1, here it is j and here it is minus j. Fine. So whenever I have negative powers, the order that I will follow is anti-clockwise, and whenever it is positive powers, that time we will follow clockwise direction. So then w 4 raised to minus 1 is nothing but w 4 raised to minus 1 is j. So I will have j, x1 of k is minus 2 plus 2j, multiplying I will get minus 2j, this will be plus 2 j square, which is minus 2. So I will get minus 2 minus 2j. Okay. Then we will go for x2 of 2, which is nothing but w 4 raised to minus 2 x of 2, which is nothing but w 4 raised to minus 2 is minus 1 into x2 is minus 2, then I will get 2. So this is x2 of 2, which is 2. Okay. And lastly, we will go with x2 of 3, which is equal to w 4 raised to minus 3 x of 3. So w 4 raised to minus 3 is minus j. Okay. X of 3 is minus 2 minus 2j. So when you multiply, you get plus 2j, minus of minus will be plus and then j square will be minus. So it will be minus 2. So you will get minus 2 plus 2j. Okay. Therefore, we can say x2 of k will be equal to 10. Then I have x1 of is minus 2 minus 2j. Then we have 2 and then we have minus 2 plus 2j. That is x2 of k. Okay. So, similarly, we can go for x3 of n. Now, x3 of n is given as 3, 4, 1, 2, whereas our x of n is 1, 2, 3, 4. So, now here if I shift the signal x1 of n to the right hand side, what will happen? If I shift once, 3 will take the position of 4, 4 will be dumped out, 2 will come, 1 will come on the 2's position, 2 will come on 3's position, who will take 1 position is 4. Then if I shift once, shifting once to right hand side will produce x of n minus 1, which is nothing but 4, 1, 2, 3. Okay. Then if I shift again, shifting once more, once to RHS, now it is x of n minus 1 which will be x of minus 2. I am shifting this once, then it will be 3, 4, 1, 2, because 3 will be dumped out here, will come from here, 2 will come on the 3's position, 1 will come on 2's position and 4 will come on 1's position. So, it will be 3, 4, 1, 2, which is similar to this given sequence. So, I can write as x3 of n is equal to x of n minus 2, that is a relation. Again we can obtain the x3 of k by using time shift property. In this now the L value is 2. So, by using time shift property with L equals to 2, we get x of n minus 2, its DFT is nothing but e raised to minus j, because it is minus 2 pi 2k by 4, let us say, x of k, right. So, I have here 2 for L and the k factor. So, I can write this as e raised to minus j 4 pi k by 4, right. So, L value is, let us say, 2. So, the Twiddle factor here will be W 4 raised to 2k. So, I will write minus, so I have to write plus 2k. Okay. So, I can write x2 of k will be equal to W 4 raised to 2k x of k. Now, put k is equal to 0, you get x of 0, which is this factor will be 1, and x of 0, which is nothing but 10. Then put k equals to 1, you will get x2 of 1, x3 of 1, x3 of 1 will be equal to W 4 raised to 2 x of 1. Again circle W 4 raised to 0, W 4 raised to 1, W 4 raised to 2 and W 4 raised to 3. Order is in the clockwise direction. This is minus j, this is j, this is 1, this is minus 1. And for x of k, the value is 10 minus 2 minus 2j minus 2 plus 2j minus 2 minus 2j. This is x of k. Now, W3 of 1 is W4 raised to 2, W4 raised to 2 is minus 1. So, I am multiplying minus 1 to minus 2 plus 2j. So, that will give me 2 minus 2j. then x3 of 2 will be equal to w4 raised to, now 2 and I am putting 2 for k, then that becomes 4, w4 raised to 4 x of 2. w4 raised to 0 is same as that of w4 raised to 4. So, it will be 1 into x of 2 is minus 2. So, x of 3 is minus 2. Okay. Lastly, x of 3 will be equal to w4 raised to 6 x of 3. Okay. So, x of 3 is as minus 2 minus 2j, w4 raised to 6 from the previous diagram we can see w4 raised to 6, w4 raised to 4 is this, w4 raised to 5, w4 raised to 6, w2 4 raised to 2 which is minus 1. So, I will write here minus 1. So, that will give me 2 plus 2j. Okay. Therefore, I can write x3 of 3 equals to 10, then we have 2 minus 2j, then we have minus 2 and finally, we have 2 plus 2j. That is my x3 of. So, in this manner we have found 3 sequences output without actually using x definition of DFT. Now, the last and the final part. So, if we go for the fourth section which is given as x4 of n which is equal to 4, 6, 4, 6. Now, my x of n is equal to 1, 2, 3, 4. Now, looking at these two sequences, I cannot say that there is any direct relation between x4 of n and x of n, okay, because we do not see any 1, 2, 3, 4 going around in x1 of n. So, by shifting time shifting I am not going to achieve x of n directly. So, there are some other operations that need to be performed on x of n to get x4 of n. Okay. So, how will I get x4 of n? You see that I want here 4, I want here to be 6. So, if suppose I have a sequence, I want 4 in the first place, that means I can get 3 in the first place, then I want 6, so I want 4 in the second place, then I want 4 again, so I want 1 over here, and I want 6, that means I can get 2 over here. If I add these two sequence, then I am going to get 6, 4, 6, 4, isn't it? But how will I get 3, 4, 1, 2? Now, simple. If I shift the signal twice on RHS side, then I am going to get this sequence. And if I add these two sequence, then I am going to get x4 of n. So, I say that x4 of n is nothing but I will get x of n as it is plus x of n minus 2. Okay. So, this will actually give me 4, 6, 4, 6 sequence. So, therefore, I have seen that now my new the x4 of n is does not have a direct relation with the x of n, but the relation can be developed by looking logically at the given sequence. Now, to get the DFT, now we in this problem we have two operation. Now, x of 4 has two operation. One is it has an addition sign, that means it looks similar to linearity property, and then the second operation, it also has a time shift. So, I am going to use two properties in this one problem. One is a linearity property and the second one is the time shift property. Okay. Now, with the linearity property, I have two sequence x of n and x of n minus 2. When I will get DFT of x of n minus 2, there I have to implement time shift property. So, I will have a time shift property also and I will have a linearity property also. Therefore, I can say that x4 of k will be equal to x of k plus DFT of x of n minus 2. I have purposefully written it like this to show that this is the utility of linearity property. What is the scaling factor over here? It is 1. So, I have 1 into x of k plus the DFT of this sequence. Now, the DFT of these sequences, the DFT of x of n minus 2 is e raised to minus, because it is minus, it will be minus j, okay, 2 pi. Now, L over here is 2 k divided by 4, because it is a 4-point sequence, x of k, isn't it? So, my x4 of k will be equal to x of k plus, I will substitute this, but when I am substituting this, I will write it like this, w 4 raised to 2 k, because L is 2, k is a variable now, x of k. So, this is the given relation that we will be using for solving the x4 of k. Therefore, now I can write put k equals to 0. So, I get x4 of 0 equals to x of 0 plus w 4 raised to 0, which is 1, and then x of 0 again. So, I get 10 plus 10, which is nothing but 20. Now, let us put k equals to 1. Therefore, x4 of 1 will be equal to x of 1 plus w 4 raised to 2 x of 1. Again the circle, this is w 4 raised to 1, sorry 0, 4 raised to 1, 4 raised to 2 and w 4 raised to 3, okay, in the clockwise fashion, because the degree is negative. Okay. Now, this is 1, this is minus j, this is minus 1, this is j, and x of k for us is 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Now, I will use x1, which is minus 2 plus 2j plus w 4 raised to 2, it is minus 1, correct, and x1 is minus 2 plus 2j. We see that if I put w 4 raised to 0, it is minus 1, that means x1 of x1 minus x1, which is 0. So, this will give me 0. Even if you multiply, this will be plus 2, this plus 2 will cancel with minus 2, this will be minus 2j will get cancelled with the plus 2j and we will get 0. Then we put k equals to 2. So, we get x4 of 2, which is equal to x of 2 plus w 4 raised to 4 x of 2. Now, x of 2 over here is minus 2. Now, x4 of 4, that is 3 over here done, then 4 of 4 is 1 plus 1, that I will not write, and then minus 2, which will give me minus 4. And finally, I put k is equal to, k is equal to 3. So, when I put k is equal to 3, it goes x4 of 3, which is equal to x of 3 plus w 4 raised to, now 2 3s are 6 x of 3. So, that will be equal to x of 3 is minus 2 minus 2j plus, now w 4 raised to 6, 5 6, which will be minus 1, and then again minus 2 minus 2j, this is also going to be 0. So, if I write x4 of k, then I am going to get 20 here it is 20, then 0, then minus 4 and then 0 again. So, that is the given answer. Thank you.